The aerospace industry has witnessed tremendous technological and innovative growth in the last couple of years. Among those breakthroughs, drones, also known as unmanned aerial vehicles, or UAVs for short, have been emerging as revolutionary tools that are redesigning logistics, transportation, and social structures. Kawasaki, an engineering and manufacturing leader in the global aerospace arena, stepped into this movement with his revolutionary K-Racer project. This revolutionary vertical takeoff and landing drone aims to address critical logistical challenges while offering solutions to pressing societal issues. But is Kawasaki's drone technology a potential game changer in cargo delivery? First, we gotta start from the genesis of the K-Racer project. Kawasaki entered the unmanned aerial systems field with its high-performance engine and helicopter development skills. It began the K-Racer project with the recognition of the growing need for efficient automated delivery systems. This endeavor focuses on creating a VTOL aircraft designed to solve logistic problems, particularly in challenging environments where additional transportation methods falter. The prototype of the K-Racer X1 by Kawasaki, which attempted to create a drone that would handle significant cargo, was tested for the first time with airlift operations back in 2020. The prototype used a Ninja 8R supercharged engine, letting it carry up to 220 pounds of cargo. It marked a critical landmark in proving that their vision was in fact feasible. If you're enjoying this video so far, like and subscribe for more as we cover K-Racer's project's origins, its impact on social issues, and the successful proof of concept, as well as us exploring the K-Racer X2's design, self-driving trucks, entry implications, and unique features of Kawasaki's K-Racer. Stay tuned for more insights. So one of the things is overcoming social issues. The innovation of Kawasaki is not limited to logistics. K-Racer is also working towards solving severe societal problems in the form of labor shortages that have been witnessed due to low birth rates and aging populations, especially in regions like Japan. The cargo delivery drone from K-Racer will solve this problem by ensuring that basic commodities are supplied to remote and inaccessible areas. Let's dive into the proof of concept. After the development, Kawasaki performed proof of concept tests with high rigor to validate the performance of the drone in real-world scenarios. For this purpose, a delivery robot was loaded with cargo, which was then automatically boarded onto the K-Racer. The drone then completed a fully automated flight before landing and releasing the delivery robot to its final destination. This sequence demonstrated the potential of seamless and efficient operations, a key requirement for commercial viability. Now, let's talk about the evolution of design, more specifically the K-Racer X2, because the experiences garnered from the X1 prototype gave birth to the K-Racer X2. Some improvements in the X2 model are as follows, one of them being higher payload capacity. The X2 has a payload capacity of up to 440 pounds, which is twice the payload capacity of the previous model. This improvement will allow the X2 to carry heavier and larger payloads, thereby making it more applicable to various industries. Increased capacity also puts it in an important position in emergency relief, as it can bring significant aid to devastated areas. The next thing is altitude capabilities. The X2 flies with precision of up to an altitude of 10,000 feet to effectively deal with the challenges of mountains and low oxygen conditions. It also has enhanced thrust because gasoline-powered engines on the X2 give greater lift and reliability in those altitudes. These developments were demonstrated at test flights over the Nami runway and Fukushima robot test field in early 2024. The performance under extreme conditions has confirmed the use of the aircraft for a range of logistical purposes, such as remote or disaster-stricken operations. Let's talk about a new generation of self-driving trucks though, because the success of the K-Racer X2 has opened doors for Kawasaki to envision a broader implementation of automated freight transportation. This technology could revolutionize logistics in isolated regions, delivering goods where conventional methods are either too costly or impractical. By leveraging advanced automation, Kawasaki's drone system has the potential to 1. Reduce costs. The system cuts down on labor costs since operations are automated. Further optimization of routes and fuel usage can also save more for the system, which is more cost-effective than manual freight transport. This means that automated freight transport is particularly attractive to organizations with tight budget constraints. It also improves efficiency. The constant operation of the drones allows cutting down on the delivery time immensely, bypassing traffic and geographical barriers, ensuring timely delivery under challenging conditions, and real-time monitoring and adjustments to ensure seamless operation with minimal delays. It also improves accessibility. Drones reach areas inaccessible by traditional vehicles and ensure vital supplies reach the intended recipients. In disaster relief and servicing sparsely populated areas, this technology bridges the logistics gap. They overcome natural obstacles such as mountains or flooded zones to provide life supports in times of emergencies. This also has industry-wide implications too, as Kawasaki's advancements in drone technology are part of a larger movement within the aerospace sector. The rapid development of vertical takeoff and landing aircrafts have become a transformative force in both logistics and passenger transport. By reimagining how goods and people move across urban and remote areas, this shift is reshaping industries worldwide. One product of this innovation is the hybrid electric VTOL aircraft, E-Starling from Arc Aerosystems. The E-Starling is a clean vehicle designed for urban and intercity passenger transport for clean mobility. This VTOL technology can be used for both freight and passenger solutions. It is more environmentally friendly compared to traditional aircrafts and minimizes emissions while maintaining efficiency. Its ability to bypass congested cityscapes with easy connectivity to vast remote areas indeed makes it able to redefine urban mobility. For example, with aircraft like the E-Starling VTOL, such technology becomes significantly more viable and applicable to various humanitarian relief activities and emergency service operations. Examples include delivering much-needed relief services in difficult areas after natural disasters, and the speed of evacuation and rescue effort through these dense cities, all concerning public infrastructures and introducing a new stage of access and responsiveness. With Kawasaki and Arc Aerosystems continuously setting new benchmarks, it's no surprise that the influence continues to resonate with the aerospace industry and even the rest of society. But let's compare Arc Aerosystems versus industry leaders. Because Arc Aerosystems has focused on developing hybrid electric propulsion systems, allowing for it to have extended range and flexibility. Their prototypes, such as the C600 heavy lift cargo drone, highlight the industry's shift towards eco-friendly solutions. Similar to the K-Racer, these drones prioritize sustainability, as hybrid systems reduce environmental impact. They also prioritize efficiency, as advanced propulsion systems enhance flight duration and cargo capacity. Meanwhile, companies like Leonardo have focused on VIP transport and offshore operations. The AW609 tilt-rotor aircraft, with its hybrid design for vertical and horizontal flight, represents a significant step forward in adopting VTOL technology to diverse applications. Although geared towards passengers, Leonardo's approach aligns with Kawasaki's vision of versatility in VTOL technology. Despite industry perils, Kawasaki's K-Racer stands out for its unique combination of features. One, its engine technologies. Ninja H2R takes advantage of the motorcycle engineering genius of Kawasaki's K-Racer's engine, which endows the best power and performance at the same time. It is also high altitude and operation based. Unlike all the VTOL drones, focusing on urban operating environments, Kawasaki built K-Racer for rugged to remote terrain usage. Also, we gotta talk about its combination with delivery robots, because the integration of autonomous delivery robots by Kawasaki is in fact creating the end-to-end solution for its logistics business lines. The promising K-Racer project faces regulatory challenges, such as airspace regulations. This is still a significant challenge for commercial drone operations. Public acceptance is another major challenge. The trust in automated systems is necessary for mass adoption. The high development and R&D costs may affect the scalability of this technology though. There's also opportunities because the potential rewards far outweigh the challenges, as Kawasaki can expand market reach, entering untapped markets including disaster relief and military logistics. It can also collaborate with governments by partnering with regulatory bodies to create frameworks for drone operations. And they can also leverage their expertise, as they can use their engineering legacy to stay ahead in the competitive aerospace market. So, what's the future of cargo delivery? While continuing to develop and perfect the K-Racer project, implications for the logistics industry are fundamental. In a world where some regions are unrepresented or are not yet par with good infrastructure, drone technology will become the nerve of the future supply chain. With minimal manpower vehicle involvement, Kawasaki drones ensure smooth transport, traversing hostile terrains for unmatched speed and precision in deliveries. This new technology may revolutionize the face of logistics. Autonomous drones can help reduce operational costs significantly by saving on labor and fuel usage due to efficient routes flown. Moreover, the reliability they provide is unmatched. These systems are designed for near-perpetual use, impervious to weather delays or human efficiency limitations. In addition, the emphasis Kawasaki is placing on high-end automation opens the doors for its mass implementation in all industries, from carrying medical supplies to remote clinics to enabling e-commerce companies to meet their demands for rapid delivery. Freight drones are going to change the game when it comes to convenience and accessibility. This vision makes Kawasaki a pioneer, leading the charge into a future where cargo delivery is faster, safer, and more efficient than ever before. The K-Racer project shows the commitment Kawasaki has to innovation and its impact on society. By reducing logistical challenges as well as being part of solutions for the problems of an aging population and labor shortages, this K-Racer drone is evidence of the impact that technology can make. Not only is it a path-setter in terms of efficiency, but also a testimony to the contribution automation makes in building more inclusive systems of transportation. K-Racer is the future, and Kawasaki refines its vision since cargo delivery is faster, safer, and much more sustainable. As the aerospace industry becomes more autonomized and sustainable, Kawasaki reminds us that, shortly, speed is not the only point. Accessibility and resilience are part of change, and K-Racer is a glimmer into this world where technology bridges gaps, turning challenges into opportunities. Ready to see how Kawasaki's K-Racer is revolutionizing cargo delivery? Like, share, and subscribe to stay updated on the latest in drone technology and innovation. And if you're eager to dive into more high-stakes action, then don't miss our thrilling exploration of the carriers.